in this day and age almost feels like a necessity.
Oh, I would agree with you. I would agree.
Yeah.
Yeah, I was sort of chuckling to myself about the zombie hurricane. The meteorologists always have the best terminology.
Mm-hmm.
Hey folks, welcome back to another fantastic edition of our Facebook Live series with the Franklin Institute. Of course, I'm Dr. Rachel Valletta, environmental scientist with TFI, and I'm bringing you a very special guest and friend of ours, friend of our educational programming rather, Sean Sublette. He is a meteorologist with Climate Central, a group that I hope to chat about in just a little bit. We're here today to be taking all of your questions as they relate to weather and climate. Today was a little bit of a late breaking episode, and we're doing it in response to some of our viewers and some of our audience's interest in understanding what the heck is going on with some of these intense wildfires we're seeing, certainly up and down the West Coast, and also a rather intense hurricane season playing out on the East Coast. So that's why we've brought along a weather expert with us to help contextualize that. Sean, as mentioned, is a meteorologist. He works with Climate Central's Climate Matters program, and he helps train meteorologists improve their ability to communicate not just on weather, but on how it relates to the overall context of climate. He was a former chief meteorologist at WSET in Lynchburg, Virginia. He's been a meteorologist also in Roanoke, chief meteorologist in Lynchburg. The Virginia Association of Broadcasters awarded him the best morning show 6 times in 8 years. So he's the real expert here in presenting to all of you. Sean, the first time I heard you speak was actually a presentation you gave at a seminar. And I have to admit, I sort of took crib notes maybe a little bit on your presentation style. I've adopted this sort of person first framing when we talk about natural disasters and how they relate to climate. So first off, thank you. Let me express that gratitude to you for letting me learn from the experts.
Well, thank you so much. And thank you, to Rachel, to you and for everyone there at the Franklin Institute for doing their best to communicate the importance of science and the love of science in a natural world where we're more dependent on understanding environmental science as a whole and all the natural sciences to better make decisions as we go forward. And what's obviously a difficult time, and I know it's difficult for y'all there as well, the Franklin Institute. So thank you for staying on it. We appreciate that as well.
Yeah. Likewise. So lots of love here, folks, as always, at TFI. So let's jump right into it, Sean. As mentioned, of course, it's a fantastically intense wildfire season in California right now. Just this morning from Cal Fire, the update on the year, I believe, is that we're battling right now upwards of 30 active fires in California. There's about 18,000 firefighters on the ground there. Help us understand a little bit about why this wildfire season has been so intense. We're seeing right now, I believe, correct me if I'm wrong, 3 of the largest wildfires on record ever that were burning simultaneously in California this season. Can you help us understand that a bit?
Yeah, that's exactly the first point I wanted to articulate. I mean, fire is certainly a natural part of the ecosystem in the Western US, especially in California. And let's be fair here, there's some management issues going on. Having said that, though, in a warming environment, which we have seen here over the past several decades, we're more susceptible to drought. Droughts happen, but in a warmer environment, they get worse because there's more evaporation out of soils. There's more evaporation out of plants, so you have more fuel to burn through once fires get started. So there's also always a small natural variation, but what we're seeing is that variation kind of going up and up and up and up like this in a warmer and drier environment. So you're much more susceptible to these wildfires once they start. The end result being, as a result largely of the changing climate, they spread faster and they spread farther. All right, so they've always been there, But in this type of environment, we're more susceptible because they travel faster and they travel farther.
Right. Sean, as you're talking there, I'm going to go ahead and share my screen, an image that you shared with me beforehand. And I like this little tidbit, this little factoid here. Yeah, it's sharing with us data that you can help us explain, of course. And we're seeing that, with the impact of climate change, of course, as mentioned, overall, we're seeing more acres burned.
Yeah, so we'll just kind of walk through this because there may be a lot to unpack, but that white bars is basically the average temperature annually across the western United States, basically west of the Front Range of the Rockies. And it's gone from about 48.3 to 50 degrees, so almost 2 degrees, which doesn't sound like a lot, but when you average that over that distance of time, length of time, over that large of a distance, it's not trivial. So that's going up. And then you see all those bars are the thousands of acres that burn. And again, as I said before, there's always these year-to-year variations, but that longer-term trend over the past 40 years is undeniably up. And of course, 2020 isn't even in this one yet, because when we put this graphic together, the number was changing too rapidly from day to day to day. So obviously, once this season comes to a close, or the year comes to a close, that'll be updated. But the end result here being that these larger fires are becoming more dominant than they have in the past.
Right, sure. So I'm going to stop screen sharing there. And one factoid that really, really pops out to me, and certainly this trend that you've just shared with us fits well into it. From the National Climate Assessment, they report that the area burned thanks to climate change perhaps is double what it would have been without the impacts of climate change. And it is complex fire science, but on the other hand, it's not really so challenging, right? It's hotter, it's drier. That creates essentially more tinder, and that's what we were sitting on along the California coastline. Now, the fires that broke out in late August were kind of unusual in that they were lit by lightning storm. Is that correct? So can you help us understand, why is that a common or not common phenomenon? I was actually surprised to hear that was not so common a phenomenon.
Yeah, especially there in, greater San Francisco, the Bay Area, and slightly inward into central and northern California. Southern California, Arizona, New Mexico, a lot of the Southwest will get dry thunderstorms. And that's not as something we're as familiar with here east of the Mississippi River, but that's a much more arid climate in the first place. And the thunderstorms are there to develop because there's less moisture around. The bases of thunderstorms go much higher in the sky, and the liquid in the thunderstorms that starts to rain out dries up before it ever gets to the ground. But you still get the lightning. So that's one way to get the regular lightning started fires in the Southwest. What was unusual about what happened in San Francisco and central and northern California was that there was a decaying tropical system that came inland and spawned a lot of lightning, a vastly unusual amount of lightning. And I would say that I wouldn't attribute that to anything specifically climate related. I think that in particular event was probably just a little bit of a natural fluctuation. I think we really need to go very deep in the weeds to try to see if that was a climate issue. But the point being is that it had been a very dry, they were already in drought in central and northern California, much more than in Southern California. So a lot of that area was primed for wildfire. And of course, the last, let's say 3 to 4 weeks there have been unusually hot. And in fact, another very hot spell is on the way for the Western US here next week. I mean, we're going to cool down a lot next week here in the Eastern US. And oftentimes when it's cool in one half of the country, it's hot on the other side. And that's what we're going to see. So there's going to be another big issue going forward. So they're not out of the proverbial woods yet by a long shot.
Sure. And so let's touch on a couple points there. You mentioned climate change fueling any one storm. We actually had a viewer question about that. And I'd like to return to it because I think it's quite pertinent to the next topic of hurricanes. So let's go ahead and put a pin on that. Thanks, folks, for submitting that question. And again, so the impact of climate change, of course, doubling perhaps upwards of wildfire area burned without the impact. And in this case, we saw an unusual dry thunderstorm and lightning strikes that set off some of those early season fires. So let's, Sean, switch over to the East Coast here.
Yeah.
So wildfires on the west, we're seeing an unusually active hurricane season. In the North Atlantic, we saw upwards of 5 storms simultaneously. That's only the second time on record. Correct me if I'm wrong there.
Yeah, that doesn't happen much.
Doesn't happen so much, right? So help us understand why meteorologists believe we're having such an active hurricane season.
There are a couple of things involved, and like the wildfire season, there are certainly going to be year-to-year variations. One of the things I like to caution people is that because it's like this year, doesn't mean every year is going to be like this. You know, I get a little antsy about terms like the new normal because you know, one year can still be an aberration. Having said that, we knew at the beginning of the hurricane season, going back into May, that the conditions that lead up to an active hurricane season were in place. And what do we mean by that? There's something called the El Nino Southern Oscillation, all right, which is a fancy word, a fancy term, meaning the water is unusually warm in the tropical Eastern Pacific Ocean. What does that mean? Well, that ties back into a special wind pattern that we see across the tropics, right? And that particular wind pattern either can tear apart tropical storms or they can allow them to develop a little bit more. This is called wind shear. In other words, if the winds are going at different speeds, at different levels in the atmosphere, that's wind shear. If they're all going about the same, that's very low wind shear. And we're going into a cooler, what's called a La Nina phase, and that's associated with very low wind shear. Right? So that means it's going to be easier for tropical storms / hurricanes to develop. And we also saw that the water temperatures were far above normal. That's the fuel for the storms. So they've got to form in the first place, and the shear depends on, it governs that a lot. Then once they form, what kind of fuel do they have to keep going? And we saw that with the abnormally warm water temperatures. And this was seen in the Gulf of Mexico and the tropical part of the Atlantic Ocean. So those are the two key things that we knew going forward into this season. So this is probably going to end up being even more active than 2005, which to date is still the most active season in the Atlantic on record.
In terms of total numbers of hurricanes.
Total numbers, yes. I mean, and to be fair, we've seen a lot of very small storms. We have not had as many Cat 5s as we saw in 2005. But we have had 9 systems, whether they were tropical storms or full-fledged hurricanes, make landfall in the U.S. And one of the even harder things to determine is what does this mean for landfalling storms? I mean, because, you know, the old adage, if a storm is out in the Atlantic, nobody cares because it doesn't hit anybody. So there's just not a lot of good data about what does this mean for landfalling hurricanes. Excuse me. But if you have more systems out there, statistically, you're going to be more likely to be hit by one. So that's why we're still concerned. As we think about a warming planet going forward, a lot of the early evidence doesn't suggest that there's going to be more of them on a regular basis. But with warmer water, warmer air, more evaporation into the storm, more energy, when the storms do form, they will have the tendency to be stronger, put down more rain, and produce higher storm surge. So that means flooding.
Sure. Okay, so you got ahead of my next question there. So no, you're on the ball here. And it really was, you know, asking about how these climate trends, so overall warming trends across the globe, both of course, water temperatures in the ocean and overland temperatures, are they impacting at all the La Nina, El Nino cycle? And are they impacting hurricane patterns? You shared with us there that maybe we thought there were going to be more frequent hurricanes, but it looks like right now, perhaps it's just that they're more intense. We haven't seen that manifesting into more storms. How about that El Nino, La Nina cycle? Are we seeing any kind of shift in that cycle?
There's very middling evidence on that one way or the other. There is the anticipation that the El Ninos will be a little bit stronger. But again, we're looking at a departure from the normal, all right? So as we see the whole climate warm, let's just pick a number here for a reference point. Let's say that part of the tropical Atlantic averages 80 degrees, all right? So when it's cooler than normal, maybe it's about, you know, the La Nina phase, maybe that's 75, 76. In the El Nino phase, maybe that's 84, 85. all right, just as a reference point.
Mm-hmm.
So we go into a warming climate, 30, 40, 50 years from now, maybe the average temperature is 84, 85 because we've warmed up so much. That's probably a bit extreme, but again, for a reference. So then do we say these La Ninas are now only 80, 81 and the El Ninos are 89, 90?
Sure.
So, and that in turn, again, that's going to feed back more moisture into the atmosphere and give you the potential for stronger storms. As we're going into a La Nina phase this year, that tends to allow cooler and relatively drier air to move into the eastern United States more frequently than in a La Nina year. And that's basically for the wintertime, but kind of putting the cart before the horse there.
Yeah. Okay, so touching, of course, on the complexities of any one of these weather phenomenon across the globe and climate phenomenon, and we always, try and clarify, of course, that when we're talking about weather, we're talking about those short-term precipitation and temperature patterns. So Sean is looking at that on the day-to-day, the week-to-week, but those climate records need to be multi-decadal. So a climate record, by definition, has to be at least 30 years of those weather records that Sean hit on. And of course, we don't have a crystal ball. This is why understanding climate change is so complex. It's hard enough for us to even understand a singular storm system or a singular phenomenon, never mind how it's interacting with others and over time as well. So thanks for hitting on that complexity for us. So let's come back to that, our viewers' question about if climate change can be responsible for any specific storm. In the case of hurricanes, there's this new field of climate attribution that's sort of starting to develop. Can you help us define what climate attribution is and what are some of the early studies finding on the relationship between climate impacts on singular hurricanes?
Yeah, this started being a thing about 10, 12 years ago, trying to determine how much climate change impacted a specific weather event. Some important takeaways from what you said. Climate change doesn't cause anything. It doesn't cause an individual weather event. We try to caution people, do your best not to frame it that way. There's always weather. What climate change does is take these weather things, these bad weather events, if you will, things that impact us as humans, it makes them a little bit worse. All right, so maybe that category 3 storm is now a cat 4. Maybe instead of getting 8 inches of rain, we got 9. Maybe instead of our record high being 101, now it's 103. So it's not suddenly changing every individual day's weather event, but it plays a role in making those types of things worse, if you will. We don't get as cold as we did 30, 40, 60, 80 years ago. We still get cold, winter still comes, but it doesn't get as cold as often. It's just, it doesn't stay as cold as long either. So, back to your previous thing about what do we see with climate change and hurricanes, there is some evidence that the forward speed of the hurricanes is starting to slow down. And we also have started to see that in some of the modeling studies, the mathematical simulations of the atmosphere. We take everything we know about the atmosphere, the oceans, the biosphere, the cryosphere. We put it all into our climate model. We test it against observations to see how good it is. All right. And if it's good, like, okay, well, let's take that simulation and project it forward in time. We looked at how good it did 100 years up to now. So how good does it go forward? So we see the potential for these storms to slow down. And if they slow down, especially once they get on land, they are going to put down way more rain. And that means more flooding.
This is what we call stalling out.
Yeah. So, it's bad enough, if a storm moves over you, but it's in and out in 12 hours, maybe you got 10 inches of rain. But if that same storm, the forward speed is slowed down, now you're looking at 15, 20 inches of rain. And this is what we saw with Harvey in Houston back in 2017. It came in and just sat there. I mean, it just sat there. I mean, there were rain gauges that measured 40 to 50 inches of rain in a week.
Extraordinary.
I mean, that's really hard to imagine unless you're living through it. So those are a couple things. And the other thing I want to touch on real quick, maybe you've heard the term rapid intensification. That's when a storm literally intensifies very rapidly. It undergoes a very big deepening over the course of 24 hours. So, you're jumping a category or 2 just in about 24 hours. And there's some evidence, mostly in the open waters of the Atlantic, that that's becoming more frequent. But there's real concern, especially in places like the Gulf of Mexico, where the water tends to be warmer longer through the summer, that is going to happen more often. And if the storm starts to rapidly intensify the center 100 miles from the coastline, that's going to have devastating impacts for people who may not be paying as much attention as they ought to be in terms of evacuations.
Right. Yeah. You mentioned Harvey there, and it's some of the devastating photos that we saw. I mean, of course, tens of thousands of folks displaced, many injured, unfortunately killed. And the photos were just extraordinary. Houses floating away. Of course, we saw entire highways flooded out. And this is the real concern with some of those heavy downpours that, just as you say, they park it over a city, over a developed area, and they sit. And this is exactly why we call hurricanes and wildfires natural disasters. It's because of this intersection of natural physical phenomenon, these weather events, with human impacts. We have developed cities and towns and areas where we live in these, unfortunately, disaster-prone areas. And as we move forward, as our climate changes, as we see temperatures warm, of course, we're seeing some of those impacts increasing. So it really is a human story. This is one thing, again, coming back to what we kicked off from, that I've appreciated from you and your group, that when we talk about climate change, it's not just a science story, it's a human story.
Yeah, exactly. I mean, there's still a lot of people who like to reference the polar bears, and that's certainly an aspect of it. But what climate change is already starting to do, and we're going to see this happen more frequently, it's going to affect us as humans, as families. It's going to affect our economy. It's going to affect our agriculture. It's going to more and more affect our way of life. The drought in the Western United States, with more people moving there, your vulnerability to drought is going to increase in a place that, you have to dam up the Colorado River a great extent to get water to drink there in the Western United States. I mean, I remember the first time I ever flew out to Vegas. It's 10, 15 years ago now. And, we're coming in, over Arizona and Utah. And I've only been to the Western US, 7 or 8 times. But the first time I went to Vegas and I could see Vegas out there on the horizon and just desert all around, all I could think was like, my God, where are they getting the water? Because, I grew up here in the Eastern US, and there's trees, there's creeks, there's streams, everything is green, it's gorgeous. You go out there, you're like, it's all just dry. So these are the kinds of things that people need to think of. It's going to impact us and our way of life going forward.
Yeah, absolutely. So you mentioned on some of the vulnerabilities there, Sean. I can't help but think about, again, as we were discussing wildfires, not just structures burning and folks locally being impacted, excuse me, but also us on the East Coast. We're all connected. I'm going to go ahead and share another screen. And while I'm doing that, folks, go ahead. You can drop your questions. We've got Sean for just a few more minutes here. You can drop those questions into our chat box. And here are a couple photos, Sean, that we were sharing beforehand. I'm going to make this full screen for you. And as mentioned, of course, vulnerabilities are going to differ depending on proximity to disasters, depending on socioeconomic statuses.
Sure.
But just because we're distant from one of these natural disasters doesn't mean that we are completely free and out of scot, as it were, from the impact. So here we're showing a pretty dramatic compilation of data that NASA put together. This is a compilation of satellite imagery and airplane collected data on black carbon measurements. Black carbon, of course, substituting here for essentially smoke plume estimates, where you see those darker red colors. You can see essentially where that black carbon was in higher concentration. You can think about thicker clouds, heavier overcast. And we can see that in mid-September, following some of those more than 300 wildfires that were burning at the time, that smoke makes its way over to the East Coast, doesn't it, Sean?
Yeah, it does. I mean, fortunately for us here in the Middle Atlantic region, the smoke gets to such a level in the atmosphere, it's so high that it doesn't affect our respiratory issues like it does in the West, where the fires are being generated. But that smoke goes so high in the sky, tens of thousands of feet, a few miles up, and that's where there are very strong winds, jet stream winds. So that smoke goes up there and it doesn't entirely dissipate. It's quite thick. And so then it gets trapped in the jet stream, and those jet stream winds ultimately take it over top of other locations, including us here in the middle Atlantic, Northeast, Southeast. And that's why we had such those hazy sunsets last week, because we had some of that wildfire smoke, fair bit of that wildfire smoke.
Sure.
Again, that's very high up, so it's not a respiratory thing. Having said that real quick, in those places where you're closer to the wildfire smoke, not just the air quality is bad, but you have this very, very fine particulate matter. You might have heard the term PM 2.5. That's because that's how tiny. It's 2.5 micrometers, a millionth of a meter, which is about a yard. And they get in your bloodstream. I mean, this is not just inconvenient, and this isn't just a problem with breathing in the short term. These are the kinds of things that can do long-term damage to your health, especially if you do have, breathing concerns, respiratory illnesses that you've been dealing with all your life.
Sure. Sean, you mentioned PM 2.5. Those of us that aren't familiar with that as it pertains to smoke particulate, you may have heard about that in the city when we think about lead cleanup. So when lead can be removed from paint, it can be potentially cast into the air, and you can actually inhale it. And in the same mechanism that Sean just shared, it can penetrate lung tissue and potentially enter the bloodstream. So let's just go through a couple photos here. Of course, we can see that smoke, as Sean mentioned, being moved by the jet stream from the west to the east coast. Pretty extraordinary coverage of the entire upper half, it looks, of the contingent US here, interacting very directly with some of those active hurricanes that we saw along the east coast. This is Paulette, that you can see my mouse over, and we'll just do one last photo here. 2 days after that initial photo, eventually Paulette moves off shore, and we can see some of that smoke beginning to clear out. We had a question from one viewer about light pollution, and I think perhaps it might have been hitting on this impact. Sean, you mentioned it's up high in the air. We're not inhaling this, but of course it does impact our day-to-day lives. We saw a few days there that dipped down quite cold, thanks to the impact of these aerosol particles in the upper atmosphere. And some of us may have seen this image. I took this from my bicycle on the Ben Franklin Parkway just alongside the Philadelphia Art Museum. You can see the sun in the late afternoon here looking like it's blotted out. It's kind of a dismal scene, isn't it?
Yeah, it gives you a reminder that we are connected. I mean, the source of those fires is 2,000 to 3,000 miles away, but this, the atmosphere doesn't care about any kind of borders or boundaries. It just goes where the wind takes it. The stuff goes up in the sky, and where the wind goes, the wind goes. So I with this particular image, that also cuts down on the high temperature during the day, because you've got some of the solar energy kind of being backscattered, if you will, from the particulate matter, and obviously changing how the sun appears to us here at the ground. The sunlight goes through those particles, and only the longer wavelengths of light come through there. That's why it has that orange look to it. But it also cuts down on the amount of energy that we're getting on that particular day. I wouldn't say that has a 2 or 3 days of smoke here doesn't play a long-term effect on the climate, but it certainly is a distinct reminder of what is going on out there.
And that connectivity. Great, Sean. We've got an excellent question from an audience member here. And this audience member asks, understanding weather and climate are different. Is it common for meteorologists to have a deep understanding of climate trends? Should we expect more information about climate change from our weather people? And I love this question, and you all are on the ball here, stealing my own questions. This is exactly what Sean works on. So Sean, can you maybe speak to that, and also I'll piggyback there to ask about what some of the best practices are when you're working with meteorologists and journalists and news folk, communicating some of the complexities of where weather and climate differ, but why we need to understand both.
Sure. And yeah, that is the core of what our program, at least my program at our office, is doing, is working with media, weather folks, meteorologists, to help them explain what climate change as a big, what can seem overwhelming topic means to individuals in certain locations. We work with some folks locally at 6ABC and BC10, KYW, who have used some of our stuff. We're very grateful for them sharing and explaining what this overarching concept means to people in the Delaware Valley. But we work with people all over the country. We've got people in San Francisco, Los Angeles, Seattle, Miami, Kansas City, Boston, Washington, D.C., who get our stuff on a regular basis to help them explain what is going on in their communities with their audiences. So for a lot of the public, the only scientists they come in contact with on a regular basis is the TV weather person. And normally it's a legitimate broadcast meteorologist. But if you go back into the 70s or early 80s, climate science wasn't something that was taught very frequently at the undergraduate level. So our job is to kind of connect people who are doing the real science, who are publishing the papers, who are doing the research. Some of the people that go up to Greenland and drill these ice cores to figure out what the air was thousands and thousands of years ago. Connect them with the people who are talking about weather on the air. All right. So we can kind of bring everybody on the same page to complete everybody's understanding of the tie-in between weather and climate. Real quickly, weather is like one inning in a baseball game, where climate is the entire season. So or maybe weather is one play in a football game, the Philly special perhaps, which was awesome. But climate was the whole football season. So how did the entire football season play out? So those are some of the key differences between weather on any individual day versus the longer term climate.
Sure. And what are some of those best practices when you're working with those news folk to really help their audiences understand climate impacts right here in my neck of the woods?
Yeah, so most of the stuff we produce has local data. All right. So in other words, this is what we've seen the temperature in your backyards, let's say in Philadelphia, let's say in Columbia, South Carolina, let's say in Dallas, Texas. This is what the thermometer has told us here over the last 50, 60, 70 years. Or for coastal locations, hey, this is what we've seen the tidal gauges do in Atlantic City or in the Chesapeake Bay over the last 50 or 60 or 70 years. This is how much we've seen the sea levels come up. Most places it's been up about 7-8 inches over the last century. The problem is that we also start to see it accelerating. And then in places like coastal Louisiana, where and to a lesser extent here in the middle Atlantic, the ground is also sinking. So the impacts are even worse from sea level rise. I mean, coastal Louisiana, I think, is probably the prototypical case of sinking land, rising sea levels. So when you add those two things up, the vulnerability is truly the highest there.
Sure. So addressing local impacts of climate. Of course, when it comes to climate change communication, we're always, if anybody here has joined me before, I always say that there are two important things we can do about climate. The first one I always say is to talk about it.
Yeah.
And when talking about it, we know that effective tactics include talking about local impacts, personal relevance, and helping folks move towards action. Let's see here. We've got one final question, if I can keep you for a couple more minutes.
Sure, it's fine.
Sean, and it pertains to light pollution. Let's see. I'm not sure. Are we talking about light pollution? Well, we didn't talk about light pollution directly here. The question pertains to the usage of fossil fuels. So if we would not pollute the night sky as much, we would save fossil fuels. Well, that seems like more of a statement than a question to me. So I'm going to try and speak to it a little bit. And Sean, maybe you can help us out there as it pertains maybe to what we were talking about earlier with some of those highly aloft wildfire particulate matter. So it is certainly true that burning fossil fuels can also release particulate aerosols we mentioned very specifically. There are very specific fossil fuel originating aerosols that impact us here in Philadelphia. For example, ground level ozone.
Yeah, that's exactly what I was thinking.
Great. So Sean, take it away. Maybe let us in on what you know a little bit about ground level ozone.
Yeah, I mean, and that's something we normally see in the summertime because it is a photo reaction, if you will. It's light. The sun comes out and there's a chemical reaction going on with exhaust and that type of thing to create the ground level ozone. And I think sometimes people get confused. Ozone, well, that's the stuff way up that protects us from ultraviolet, which is great when it's a few dozen miles up. But ozone down here, you want to breathe it because it's really bad for your lungs. But this is something we see most often during the summertime because sunlight and heat and these other fumes that are coming out of internal combustion engines are what create this. And to her point about light pollution, no question, especially if you're into astronomy, the light pollution is a big deal. That's why you want to go out to the Pine Barrens in South Jersey to do a little astronomical observation. But yeah, so I think that's a big issue. Sure.
Yeah, absolutely. So if there are more specific follow-ups, let us know, and hopefully we can tackle it in a future episode. But let's go ahead, Sean, and wrap up. I really thank you for giving us a good chunk of your time here today. As mentioned, I always like to end on the two things that I think are most important when it comes to acting on climate. We mentioned the first, of course, was talking about it. If you are interested or think what we discussed today is important, share it with your friends and your colleagues, your family members. The second tidbit that I always land on, of course, is to vote. Vote, vote, vote. It cannot be more prescient. We're in the middle of a presidential election, and we can vote on climate and environment issues. It's not just the presidential election happening. We also, of course, have a number of local representatives, state representatives that are up for re-election. If you're interested in nonpartisan science-based scoring of those candidates based on their voting record as it pertains to climate issues, I'm going to drop a link into our chat here. It's a resource called climatecabinetaction.org. They've got a great climate cabinet score database, which lists the top 40, I suppose, top 40 most important climate related races that are happening across the country. If you're coming to us today from Southeast Pennsylvania, we've actually got 4 local reps that are on that climate cabinet database. So go ahead, check it out, get yourself informed, and make sure that you're talking about these issues. And if you care about them, make sure that you're voting on these issues. So Sean, that'll do it for us today. Thank you again for joining us, and folks at home, thanks to you for joining us. For those questions and follow-ups, please feel free to continue engaging with us, and we'll hope to engage you next time. Everybody stay well, and we'll see you soon.
Thanks so much, Rachel. Everyone take care.
Thanks, Sean.